So I believe the audio is correct, and I'm back on day 30 of daily code log. This is a Sunday, so I will be on my maintenance day. Great. And okay, last day I did not saw two, and last was kind of difficult for me to think through it. So I will try to think about it in around 20 minutes, and if I can't do it, I will take help of the editorial and learn something new. Okay, and I haven't recorded the thought process for many of the problems since last 4 to 5 streams. That amounts to around 6 to 7 uh, problems, I think, which I need to register now live. That will be a good thing and lower my burden. Okay, great. So without wasting any time, let's get into it. Okay, so I'm on CF. Let's get to the problem which couldn't solve, and let's think about it. Mm, cake assignment was which I couldn't do. Okay, chocolate and loves cake and manager. Okay, they want to divide it in certain way so that chocolate has this amount of cake. Great. So what I can do is I can start by making this nth bit high, both the numbers, and using the shift operator, of course. And what we can do is we can simulate the process, right? But we need to know uh, how to choose that should we divide the should we have chocolate or should we have vanilla. This is the same problem, I believe. Okay, let's think through it on the code editor. Okay, let's remove these. Last day's implementation are as good as nothing. So we have say 3 and 3, which is problematic, and 3 and 5. Great. Now we will give everybody one shift 3 and one shift 3 places, which will amount to 8 and 8. Now, how do we decide that chocolate needs 3, which is observation required is less than given, or or we can say is 2x required is less than half, right? Observations same, we give 8 and 8, but here 2x required is more than half, right? Great. Now, so what we do is we can this is a point of difference between these two. This is required. So this means last step we cannot halve it and get tough. So what we did observe in this final answer was we have 8 and 8, then we have 4 and 12, then we have 10 and 6, then we have 5 and 11. This was the step which will be roughly exactly equal to having the first one, having the second one, and having the first one. This is the sequence that we want here. Here, what do we want is 8 and 8 we have. Then we increase it. Then we do just opposite. We have it. And we have it again. So we get 3 here. So this is equal to half the second one, half the first one, half the first one. Okay. These are the desired results. So did we see when is and required is less than half, then we know need to have the other. Okay. So now we know that now this is given. Now 12 double of 12 is okay. Now how do we choose that we want to have the first one? It's more than required or what? It was also more than double the required, right? So do we need to have the other? No. We cannot have the other because half is not twice. If we have it, if we represent them in terms of binary systems, then the first one was 1 0 0 0 and this one. Okay, next one was 12, so 1 0 8 and 4. Okay, this one was 1 this. Okay, now we make it 6, so it will be 4. Great. Then what we did was it's a 10, 1 0, 1 0, and then we did what was it was 3, so 0 0 1 1, and it was 13, so 1 1 0 1. This is the sequence. We see this is the number, and we want to achieve 3. Achieving 3 is this digital signature or whatever we say. So we first create it, I believe, then we shift it. Okay, same thing. 1 0 0 1 0 0 0 1 0 0. 12 was 1 1 0 0. 10 was 1 0 1 0. 6 was 0 1 1 0. 5 was 5. 4 and 1 0 1 0 1. And 11 was 1 0 1 1. So do we see any pattern here? If we construct backwards, दोनों का सम कितना है? 16 16 16 and 16. Always the sum will be 16. That means sum is preserved, something is constant. If we solve it, so say we need the other number to be 11, right? 11. Then 5 is smaller than 11, so 5 is the final form. That means the 5 halved or something added to 5. So if 5 halved, then it added here, right? 10 and it was less, so 6. Another scenario, if 5 was added something, then it could be 4 and 10, but we need to preserve the 16, so 4 and 2, and how do we get 4? Half 10 and 6 and 5 and 11. गोल गोल घूम रहा है. Any other combination cannot be reduced and it will circle around, I believe. So fixed number of patterns है जो कि sum 16 ला सकते हैं कि नहीं? Okay. We talked about bit masking. What are we doing to? आस्किंग थोड़ा टफ तो होता ही है, बट ठीक है. हाउ डू वी डिसाइड? ये सब छोड़ो. ठीक है, ठीक है, छोड़ना नहीं. आई वांट टू नो कि हाउ डू वी डिसाइड कि these are the stuff. कैसे डिसाइड हुआ कि in this case I want to have the other, in this case it's about backtracking and stuff. So glitter recursion, इसको half करके आगे बढ़ना है सारा तरीका. then complexity क्या होगा? Largest number is of almost 50,000 I believe. Largest number because 60 है, so it can be around 50. And do we need recursion? कि साफ करो फिर देखो, साफ करो फिर देखो. I need a tutorial or hint. Hint is other descripted me. You can backtrack from the final step. Oh, okay, 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 okay. Okay. It said you can backtrack from the final step. So what I was doing is, say, say, 5 है, तो other will be 11. Then you can backtrack from the final state to odd number. So you can backtrack from the final state. Whether 5 or 11 है, then it should be 10 and 6. How do I know it's 10 and 6? Because it can be हो सकता है 4 or 12, but 4 and 12 is not possible because कोई तो हाफ होना चाहिए, है ना? Something should double. So neither is doubling. So either 22 ये डबल होके 22 हो जाए, तो 22 होने के लिए doesn't have enough juice. Okay, it's great. तो ये डबल कर सकते हैं and it can give it. Great. अरे तो सॉल्व हो गया ना जी, हो गया तो सॉल्व हो गया. It cannot double because it doesn't have enough. So it can double, तो 6 चाहिए, 4 और 12 कर दो. सेम होने तक करना. And तो ओके ओके ग्रेट। जो सोचा था वर्किंग वर्किंग वर्किंग। तो 4 को डबल किया जा सकता है, 12 को किया जा सकता है, तो 4 को किया जा सकता है 8 हो जाएगा एंड इट कैन गिव गेट हो गया। अरे यार, हिंट हेल्प, थैंक्स थैंक्स हिंट। Wow, feels great, feels really great. Okay, let's put it up. um uh, we have to put the स्टैक एक लेना होगा ताकि रिवर्स में प्रिंट कर सके। वाइल लूप चलते हैं, वाइल दोनों सेम का मतलब एक ही कंडीशन है कि दोनों सेम हो सकता है क्योंकि हाफ है, फिर हाफ से हम लोग डेविएट कर रहे हैं। सो वाइल सी नॉट इक्वल टू वी, ओके, सी इक्वल्स टू एक्स एंड वी इक्वल्स टू, we can इक्वल्स टू नहीं देके भी ऐसा ही नहीं कर सकते ऐसे, और v होगा टोटल सम जो है अराउंड 16 और 16 में से x माइनस कर दो तो हाफ माइनस एक्स और हाफ होगा ठीक है। Great, now I have all the variables. ठीक है, ऑलरेडी हाफ है तो फिर स्टैक में कुछ नहीं जाएगा। while st.empty, that was a great stack dot top, फिर पॉप करना है। नहीं, हाँ, उसके बाद ही प्रिंट होगा, बाद ग्रेट। ओके, नाउ देखते हैं कौन अफोर्ड कर सकता है डबल कराना। तो कैसे देखें, जैसे कि 4 है और 12 है, कि चेक की 4 को और डबल करने के लिए कितना चाहिए, इन सी मोर इक्वल्स टू 2 इंटू सी। तो बेसिकली हमको और डबल करने के लिए और सी चाहिए, और सी चाहिए, और इफ सी, इज लेस देन इक्वल टू v, मतलब c लेस है, जो छोटा है उसी को डबल किया जा सकता है दोनों में, है ना? Remember the sequence, it's like 4 12 then 10 6 then 5 11. So the smaller one gets double, smaller one gets double, smaller one gets double. If c is smaller than v, जो छोटा है, अगर ये छोटा है, ये छोटा है अगर, so what we have is this, what we have is st dot push I believe 2, ठीक है, क्योंकि दूसरे वाले को else st dot push 1. ओके, अब दो काम करना है, हम बस को बड़ा करना हो, नहीं तो इन्फिनिटली चलता रहेगा, राइट? तो पुश 2 किए, नाउ व्हाट वी नीड टू डू इज, c छोटा है तो c को डबल करना है और v में c माइनस करना है, v माइनस इक्वल्स टू c एंड c, ठीक है, c को ट्वाइस कर देना, else c माइनस इक्वल्स टू v एंड v टू v को ट्वाइस कर देना, एंड दैट्स हाउ इट वर्क्स. चलिए आई हैव डन, हो चुका है. Can int hold shift 60? I think it's working. Reloading. Okay. Okay. तो दूसरे को हाफ करते जाना एंड हाफ 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 एंड यू गेट, ये नंबर बड़ा हुआ, मेरे को हाफ करना है, 1 1 1 उल्टा हो गया. अगर c छोटा है, ठीक है, if c is small, if c is small, मैं देखता हूँ, देख इसके ऊपर था 8 8. now I see c is small, then I print 2, मतलब यहाँ पे 2, I see 1, है ना, मतलब ये स्मॉल है तो ये स्मॉल है, मतलब इसको स्मॉल किया गया है, इसको स्मॉल करना है रिवर्स ऑर्डर में. ओके, ये स्मॉल है मतलब इसको स्मॉल किया गया है, और हाँ, ये स्मॉल है मतलब इसको स्मॉल किया गया है, इट वाज मेड स्मॉल, it was made small. Okay, I believe this works. Okay, I believe this works. There should be a 0 somewhere. Yeah, there's a 0. This works. इसको हाँ, ठीक है, ठीक है, 2 1 1 is correct, 1 is correct, 1 to 1 is also correct. वो देख के चल रहा है भाई, orgasmic. Let's submit it. Great, great. I could do it. Feeling happy. This line meant nothing कल, but आज मुझे इससे सारा समझ में आ गया. Oh, no. It really depends on the state of the mind. किस तरह से information को perceive कर रहे हैं. I think इसमें फंस गया. Intern long cannot take 60 नहीं ले पा रहा है. I know 59 नहीं possible हो रहा है. Should I take in 256 or what? ठीक है 27 आ रहा है. So I see कि 59 है. ठीक है 59 में precision खो रहा है. So okay. I think int 256 can hold it. I have to make it unsigned and it नहीं चलेगा. अब काम कर जाना चाहिए. I had this doubt कि range won't be enough, and that was exactly what caused the error. Shift too large, I know. Undefined behavior diagnostics detected, I know. It was too large because the range was not properly calibrated. It was accessing memory that was not even at start with. Okay, allocated to start with actually. Okay, so or this doesn't have to be event. Simple end. These numbers don't have to be so large. This number, okay, for safety, where I'm doing the shift, yeah. This number should be enough. Let me submit it again. अरे यार फंस रहा है. किसमें फंस रहा है? 59 Shift too large. And do I need to mod it or something? It's still getting shift too large error. वो बस देख लेते हैं. ओह अरे यार समझ गए. शिट. अरे ये this one is treated as a default int or 32-bit width and shifting it beyond 60 is मतलब beyond 32 is creating this problem, so you need to typecast it to unsigned long and this will solve the problem. Oh why so subtle but easy. So जो भी half है, half will be a very big number and twice it create problems. Okay, I think this will solve the problem. Okay, let's submit it again and this time कोई गलती नहीं होना चाहिए. This was my first experience with unsigned and long ULL. So yeah, definitely it's a thing that I learned. अरे अब हो जा. We did it. Okay. I'm happy that I could do it without looking the code and more explanation. The line that we can backtrack and reach was enough. And before this line, I ingeniously thought of it, but couldn't proceed because it was an abstract idea and I didn't want to waste time thinking on it. I did iterate few steps, but I couldn't, or I didn't think too much on uh, what should be halved or what should be doubled moving backwards. But once I thought and gave a thought about it, it was very clear that the other can't afford doubling the first, or vice versa, because they have a fixed sum. So yeah, that felt great. Okay, so yeah, I did say that we will write the metacognition of all the past problems, but I will do it. I will do it. I will do it. My bad, but I'll do it. It's Sunday, so I'll do it. Not today, but I'll do it. So see you in the next one.